Okay, thank you, sir.
Okay, thank you.
Okay, let me start the screen sharing.
Alfonso, how is your class at school? Good?
Good. Good, sir.
Good.
Okay. For today's, we're gonna learn a new material about the composite functions. So for composite functions, it's basically there are just two of them, f of g, x, and g of f, x. So for f of g, it's basically if you have an fx and gx, you're gonna put the gx on the fx. So it basically f of gx. And the same goes for the g of f. If you have a gf, gx, and fx, you're gonna put the fx to the gx. So g of fx. Maybe it's easier to understand if you're going through the questions itself. So if we have an fx of x squared plus x, and we also have the gx of 2x minus 3, and we are finding the f of g, x. So f of gx is basically f gx, like this. So what are we doing here? That we are putting this gx, 2x minus 3, into the x of the f, this one. So we got the fx, x squared plus 2. We're changing the x with the gx. So the x is going to be 2x minus 3 squared plus 2x minus 3. So 2x minus 3, we square it. This is going to be 4x squared minus 6x minus 6x plus 9 plus 2x minus 3. We group the same variable. So this is going to be 4x squared minus 10x plus 6. So this is the solution for the f of gx. Another question, if we have like fx of 3x plus 1 and also gx of 2x minus 3. And now we're finding the g of fx. So this is basically g. The x, we change it to fx. So the g itself is 2x minus 3. We are changing the x to the fx. So the fx is 3x plus 1. So 2, we multiply by 3x plus 1. We minus it by 3. This is going to be 6x plus 2 minus 3, which also equal to 6x minus 1. So there's also some question that they are giving you the f of g and either of the fx of the or the gx and ask you to find either of the fx or the gx. So let's just say if you have the fx of 2x minus 1 and we also have f of gx that equals to 2x plus 3. Now we're finding the gx of these functions. So as you know, f of g is basically f with gx, changing the x of fx. This is equal to 2x plus 3. Now we look here. For this one, fx, we got the fx of 2x minus 1 equals to 2x plus 3. As for this one, it is f of g. So we change the x here to the g. So we got 2 multiplied by gx minus 1 equal to 2x plus 3. Now we got here 2 multiplied by gx equal to 2x plus 4. So the gx is 2x plus 4. We divided by 2. We got the gx, x plus 2. Now, what if the question is inverse? So if we have the gx and the f of g, and we're finding the fx. Now the same way of the question before. So f of g is f gx equal to x squared plus x minus 3. Now we are inserting the gx here. So the f 3x plus 2 equal to x squared plus x minus 3. So we're gonna write here. So for instance, we're making this the 3x plus 2 as a. Okay, so if a equals to 3x plus 2, so 3x equals to 2 minus 3x equals to a minus 2 and x equals to a minus 2 over 3. We're changing the 3x plus 2 into a. So this is fa equal to x squared plus x minus 3. So as we can see here, we already find the x. is a minus 2 over 3. So we're gonna insert the x, so a minus 2 over 3, we square it, plus a minus 2 over 3 minus 3. So this one gonna be a squared minus 4a minus plus 4 over 9 plus a minus 2 over 3 minus 3. So we're just gonna multiply this all by 9 to get rid of the 9 and 3 here. So for this one, we can just eliminate this. So a squared minus 4a plus 4. As for this one, 9 divided by 3 is 3, multiplied by a minus 2. So plus 3a minus 6, and 9 multiplied by minus 3 equals to minus 27. So a squared minus a minus 29 equal to fa. Oops, sorry. For this is also, the fa is also multiplied by 9. So this is 9 fa equal to a squared minus a minus 29. Now we can change the a here into x. So fx equal to x squared minus a minus x minus 29. We move the 29s to the other side into divided by 9. So this is the fx of these functions. It can be quite confusing at first, but the more you look at the questions, the more you do it, the easier it will be. Today we're just gonna try out a bunch of questions so you can all understand how it works. Another one is if we have fx of 3x plus 1 and a gx of x squared plus 1, we are finding the value of f of gx. And also we're finding the value of f of g minus 3. So at first we're gonna find the f of gx. So f gx equals to, the f itself is 3x plus 1. Insert the x with the gx, so 3x squared plus 1 plus 1. This equals to 3x squared plus 3 plus 1, 3x squared plus 4. This is the value of f of gx. Now we're finding f of g minus 3. We're just gonna insert the x with minus 3. So 3 multiplied by minus 3 squared plus 4. So this 3 multiplied by 9 plus 4. 27 plus 4 equal to 31. Next questions. We have fx of 2 over 3x minus 6 and gx of 2x plus half, and we are finding the g of fx. G of f, so g, we insert the fx into the g. So the g itself is 2x plus half. Now we insert the fx to the x2 multiplied by the fx 2 over 3 x minus 6 plus half. This one gonna be 4 over 3x minus 12 plus half. We can write it down as 4 over 3x. 12 is 24 over 2 plus half, or 4 over 3x minus 23 over 2. This is the value of g of fx. Another one, so if we have an fx of x squared plus 5 and an f of gx, that is x squared minus 2x plus 6. And we are asked to find the gx. So f of g equals to x squared minus 2x plus 6. So the fx itself is x squared plus 5, but we're inserting the gx into the x. So this should be gx squared plus 5 equal to x squared minus 2x plus 6. So this gx squared equal to x squared minus 2x plus 1. Now we are getting rid of the squared from the gx. So we just need to square root the x squared minus 2 plus 1. And for this one, x squared minus 2x plus 1 is also equal to x minus 1. We are multiplying it by x minus 1. So the gx is equal to the square root of x minus 1 squared. We're eliminating the square roots and the square. We get gx x minus 1. Another question, if we have fx of 2x minus 3 and f of gx equal to 8x minus 7, and we are finding the gx. The same as before, the fx f of g, right here, is equal to 8x minus 7. So the fx is 2x, changing the x with the gx. So 2 multiplied by gx minus 3 equal to 8x minus 7. 2 multiplied by gx equal to 8x minus 4. Gx equal to 8x minus 4 divided by 2, which also equal to 4x minus 2. Now, if we have an fx, we are finding the fx, and we have the f of g, x equal to 6x plus 11, and the gx equal to x minus 5. So we got the f of g, x equal to 6x plus 11. As we know, the gx is x minus 5. So f x minus 5 equal to 6x plus 11. So for instance, the gx, or x minus 5, is equal to a. So x is equal to a minus 5. So we're going to change the x minus 5 here to a. So f a equals to 6. The x is a minus 5. So multiply by a minus 5 plus 11. So the FA is 6a minus 30 plus 11. Sorry, this is plus 5. So this should be plus 30 plus 11. The FA is 6a plus 41. We're changing back to a to x. So the fx is 6x plus 41. Now we're gonna continue to the inverse of the functions. So if you have a function of fx that equals to ax plus b, if you inverse these functions, you're gonna get x minus b over a. And if you have the functions of fx equals to ax plus b over c, the inverse of these functions is cx minus b over a. And if you have a function of fx equal to ax plus b over cx plus d, the inverse of these functions gonna be minus dx plus b over by cx minus a. There's actually a lot more of the inverse other than this tree, but this is the basic, and I'm gonna teach you this for today. So for instance, you have fx of 2x plus 3 over by x plus 2. So you can see here, the a here is 2, the b here is 3, the c here is 1, because there is no variable over this x, and the d here is 2. So for the inverse itself, it should be minus d, so minus 2x plus b, the b is 3, over by cx, so 1x, we just write it as x, and minus 8 minus 2. This is an easy way if you want to remember this one, but there's also another way to find the inverse of the functions. So the other way is quite complicated than this one. So for instance, we are changing the fx to y. So the y equals to 2x plus 3 over x plus 2. For this ones, we are multiplying up here. So it's going to be x, y multiplied by x plus 2 equals to 2x plus 3. So this is going to be yx plus 2y equal to 2x plus 3. For this one, we're just trying to move the x to the left side and the y to the right side. So for this one, we got yx plus minus 2x equals to 3 minus 2y. Now we're trying to move the y here over to the right side. So you can write it as x equals to multiplied by y and minus 2, 3 minus 2y. So we're gonna move this y minus 2 to the right side. So x equals to 3 minus 2y over y minus 2. And now we're changing the x here to the f inverse, fx inverse. So f inverse equals to, and we are changing the y here to x. So this is 3 minus 2x over x minus 2, This should be minus, sorry. Now, this is the same as this one. We just need to minus 2x plus 3 over x minus 2. This is the long way to solve this one, and this is the short way, but we need to learn how it works first so we can understand it better later. So maybe I can show another one. So if we have an fx of x minus 5 over 2x plus 1. If we inverse this, so this should be minus dx plus b over cx minus a. If we inverse it in the short way, we're gonna get minus 1x, so minus x minus 5 plus b, the b is minus 5, and we got cx, so it stayed as 2x, and minus a, which is 1, so minus 1. This should be the f inverse. Now for the long way, we're changing the fx to y is equal to x minus 5 over 2x plus 1. Multiplying it up, so we got y multiplied by 2x plus 1 equal to x minus 5. We got here 2xy plus y equal to x minus 5. Moving all the x to the left side, so we got 2xy minus x equal to minus 5 minus y. We can also write this as x, 2y minus 1 equal to minus 5 minus y. So the x should be minus 5 minus y over 2y minus 1. Changing all the x, y to the x and the x to the fx equal to 5 minus x over 2y minus 2x minus 1. Which we're moving the x forward, so minus x minus 5 over 2x minus 1 is the same as the short way. Now we're gonna include this inverse to the f of g question that we have solved before. So if we got the fx of 3x plus 1 and the gx of 2x minus 5, now we are finding the f of g, but inverse this time. So first we're gonna find the f of g first. So f of g is 3, changing the x to gx. So 2x minus 5 plus 1 6x minus 50 plus 1, 6x minus 40. Now we are inversing this one. You can see from the one I gave before, if we have ax plus b, it became x minus b over a. So the x here minus b minus 40, so it became positive 40 over a over 6. Now if we're trying it with the long way, we got equal to 6x minus 40, y equal to 6x minus 40, 6x equal to minus y minus 40, x equal to minus y minus 40 over 6. Or we can change it to minus x minus 40 over 6, or x plus 40 over 6. Another ones, if we got the fx of 2x plus 3 and the gx of 1 over 3x minus 1, and we are asked to find the f of g minus 1 or inverse. Now we first need to find the f of g. We got 2, changing the x with 1 over 3x minus 1 plus 3. We got here 2 over 3x minus 1 plus we're changing the 3 to 3x minus 1. And we just need to multiply it by 3. So we got 9x minus 3. Then we got here 9x minus 1 equal to 3x minus 1. Now this is the value of f of g inverse. Now, if we got a question of, for instance, like f inverse of g inverse, this means that it is g of f inverse. But if we got like g inverse of f inverse, it means it is f of g inverse. Now to the questions. So if we have fx of 2x minus 5 and gx of 3x plus 4, we are finding the f inverse of g inverse minus 5. Now for this one, we are first going to find the g of f. After that, we're going to inverse the g of f, and we are inserting the minus 5. So for the g of f, we got 3 multiplied by 2x minus 5 plus 4 equals to 6x minus 50 plus 4, also equal to 6x minus 11. This is for the g of f. For the g of f inverse, we're just going to use the first way, so it can be x minus b over a, the x minus b, so it became plus 11 over 6. Now we're inserting the minus 5 into the x. We got minus 5 plus 11 over 6. We got here 6 over 6 is which equal to 1. So the g of f inverse with minus 5 as the x, we got minus 1, and we got 1. Now in the question, if we get fx of minus 3x plus 1, and we also got gx of 2x over x minus 1, and we're here trying to find the g inverse of f inverse x. So this means we are finding the f of g inverse. We're going to find the f of g first. It's going to be minus 3 to x over plus 1. It's going to be minus 6x over x minus 1 plus 1. This one is also equal to x minus 1 over x minus 1. So this equals to minus 5x minus 1 over x minus 1. Now this is only the f of g. We're finding the f of g inverse. So this we can write as the inverse, we can find it by the minus bx plus b over cx minus a. So this is going to be minus dx. So it's going to be 1x. So we just write it as x plus the b. The b is minus 1 over the cx, which is x, and minus 8. So it's going to be plus 5. This is the value of f of g inverse. And for the last question today, if we got the fx of 5x plus half, and we got gx of 3 over 4x minus 6, then we are asked to find the value of g, o, f, and first, and we're changing the x to when we're changing the x to minus 5. Now we are first going to find the g of f. G of f it is 3 over 4, changing the x to 5x plus half minus 6. This is going to be 50 over 4x plus 3 over 8 minus 6. For this one, just gonna change all to 8. So 8 divided by 4, 2, multiplied by 15, 30x. 8 divided by 8, 1, plus multiplied by 3, plus 3, and 8 divided by 1, 8 multiplied by 6, minus 48. This word is 30x minus 45 over 8. This is g of f. And now we're finding the g of f inverse. Now, if we got this kind of functions, we can turn it, if we want to turn it to inverse, we're going to just write the cx minus b over a. So the c here is 8x minus b, so plus 45 over 8 over 30. This is the g of f inverse. Now we are gonna change the x to minus 5, so 8 multiplied by minus 5 plus 45 over 30. So this is gonna be minus 40 plus 45 over 30. 5 over 30 or 1 over 6. This is the answer of the g of f inverse, and we change the x to minus 5. I guess that's all I can give for today's lessons. I'm gonna stop the screen sharing. Yep. So that's all for today's lessons. And yes, I will also send the homework for today's material in the classroom. So yeah, thank you for coming today.
Nonfi. Thank you, Nonfi.
Thank you.
Bye.
Have a nice weekend.
Yeah.